Here, two isomers of nitrophenol. One is orthonitrophenol and another one is paranitrophenol. Melting point of orthonitrophenol is 45 degrees Celsius temperature. On the other hand, melting point of paranitrophenol is 114 degrees Celsius temperature. We see a big difference between these two isomers. What is the reason behind this? Let's see the matter in detail. First of all, let's try to see melting point of paranitrophenol, in which melting point is very high compared to orthonitrophenol. Phenol at para position nitro group. This is orthonitrophenol. Here we see that hydroxyl group and nitro group are being at farthest distance, that is 1,4 positions. So in case of paranitrophenol, no bond formation is occurred between hydroxyl group and the nitro group. But here we see another paranitrophenol. Let's write another paranitrophenol. Here we see that electronegativity of oxygen is 3.5. On the other hand, electronegativity of hydrogen is 2.1. Because of the electronegativity difference, covalently bonded electrons move towards oxygen, and as a result, hydrogen gets partially positively charged and oxygen gets partially negatively charged. Similarly, here oxygen becomes partially negative in charge, hydrogen becomes partially positive in charge. For the same reason, hydrogen becomes partially positive in charge, oxygen becomes partially negative in charge. Now, partially positive charged hydrogen and partially negatively charged oxygen, attraction is created here. Here, attraction is created. So, we see that in case of paranitrophenol, hydrogen bond is formed. Because of the formation of hydrogen bond, molecules remain as cluster. To separate these molecules, high temperature is required. That is 114 degrees Celsius temperature is required to melt paranitrophenol. Because of the hydrogen bond, melting point of paranitrophenol is very high, that is 114 degrees Celsius. Now let's see melting point of orthonitrophenol. Melting point of orthonitrophenol is lower than paranitrophenol and it is only 45 degrees Celsius temperature. Let's see the matter. Phenol at ortho position nitro group. Here we see that this bond hydrogen oxygen bond is polarized. Hydrogen is partially positive in charge, oxygen is partially negative in charge. Here electronegativity of oxygen is 3.5 and electronegativity of nitrogen is 3.1. Because of this electronegativity difference, oxygen becomes partially negative in charge and nitrogen becomes partially positive in charge. Here, partially positively charged hydrogen and partially negatively charged oxygen. Attraction force is created here, a kind of hydrogen bond. But this hydrogen bond is in a molecule, not among the molecules. In case of orthonitrophenol, hydroxyl group and nitro group are being at closest distance, that is 1,2 positions. That is why in case of orthonitrophenol, intramolecular hydrogen bond is formed, but in case of paranitrophenol, hydroxyl group and nitro group are at farthest distance. That is why in case of paranitrophenol, intermolecular hydrogen bond is formed. So in case of orthonitrophenol, intramolecular hydrogen bond is formed, and in case of paranitrophenol, intermolecular hydrogen bond is formed. For the orthonitrophenol, no strong attraction among the molecules like paranitrophenol. Here, in case of orthonitrophenol, only very weak intermolecular attraction force is present, which is van der Waals attraction force. Because of the very weak intermolecular attraction force, melting point of orthonitrophenol is only 45 degrees Celsius temperature, but in case of paranitrophenol, intermolecular hydrogen bond is present. That is why in case of paranitrophenol, high temperature is required to melt it, that is 114 degrees Celsius temperature. So the reason behind difference in melting points is intermolecular hydrogen bond and intramolecular hydrogen bond. In case of paranitrophenol, molecules remain as cluster through hydrogen bonds, but in case of orthonitrophenol, molecules remain as separate molecules. That is why melting point of orthonitrophenol is lower than paranitrophenol. That is, intermolecular hydrogen bond and intramolecular hydrogen bond are responsible for the difference in melting points. Now, today, thank you very much.